Welcome in my channel Digital World. In this digital circuit lab, we will design and implement 4-bit ring counter using shift register IC 74LS95. Aim of this topic is to study and implement 4-bit ring counter using shift register IC 74LS95. Learning objectives to understand the behavior and demonstrate the implementation of 4-bit ring counter using shift register IC 74LS95. Apply knowledge and create truth tables. And the last one is to develop digital circuit buildings and troubleshooting skills. Procedure: first, place the IC on IC trainer kit. Second, connect VCC and ground pin to the respective pins of IC trainer kit. Third one, implement the circuit as shown in circuit diagram. Fourth one is connect the inputs to the input switches provided in the IC trainer kit. Fourth one, connect the outputs to the output LEDs. Next, apply various combinations of inputs according to the truth table and observe the conditions on LEDs. Next one is note down the corresponding output readings for various combinations of inputs. And the last one is power off trainer kit, disconnect all the wires connections and remove ICs from IC base. This is general block diagram of 4-bit ring counter using D flip-flop. As it is 4-bit, it requires 4 flip-flops. All flip-flops are connected back to back in ring structure. For example, output of first flip-flop is input to second. Output of second is input to third flip-flop. Output of third flip-flop is input to fourth flip-flop. And the last output Q3 is connected to the input of first flip-flop. So this is ring structure. So that's why it is called as 4-bit ring counter. This is the truth table of ring counter. Initially only Q0 is 1. For next cycle, this Q0 is shifted to Q1. For next cycle, Q1 is shifted to Q2 and the last cycle Q2 is shifted to Q3. As this is 4-bit ring counter, Q3 is connected to the input of first flip-flop. So for next cycle, next pulse, Q3 is shifted to Q0. So in this way, we can observe output on LEDs. Same truth table you can show here in the waveform. So there are total 4 pulses we require. So first clock, second, third, fourth, and finally we have to recycle again. So this is our fifth cycle. Now for first cycle, Q0 is equal to 1. For next cycle, Q0 is shifted to Q1. So Q1 become 1. For next cycle, for third cycle, Q1 is shifted to Q2. So Q2 become 1. And for fourth cycle, Q2 is shifted to Q3. So Q3 becomes 1. So in this way, we can observe LED status on board. This is IC pin diagram of 74LS95. It is a 14-pin IC. Pin number 7 is ground. Pin number 14 is VCC. As there are total 4 flip-flops, there are 4 outputs QA, QB, QC, QD. This IC works in 2 modes, right shift and left shift. So whenever the right shift operation is there, clock is connected to pin number 9, and whenever the left shift operation is there, clock is connected to pin number 8. This will be selected with mode pin. So mode control pin is pin number 6. So when mode control pin is connected to ground, the IC will work in the right shift mode, and when mode control pin is connected to VCC, IC will work in the left shift mode. In addition to that, there are total 4 inputs are there. Right now we are not using those 4 inputs. And pin number 1 is a serial input. So in case of circuit diagram, the QD is the last output. Pin number 10 is connected to pin number 1 of IC. So it will work in 4-bit ring counter. This is the circuit diagram. First connect pin number 7 to ground and pin number 14 to VCC. Next one is connect clock pin number 9 because this is a right operation. With respect to that, pin number 6 is a mode selection pin. So pin number 6 is connected to ground for mode pin. There are total 4 outputs are there. Connect to LEDs QA, QB, QC, QD. And for ring counter, the QD pin is connected to pin number 1. This is serial input. Now this is the circuit diagram of 4-bit ring counter. Now we can observe the same thing on board by doing the connections. and we can observe how really this 4-bit ring counter works. The trainer kit. Now do the connection. First pin number 10 is connected to LED. This is our QD. Next one is QC is connected to pin number 11. Third one is QB, connect to pin number 12. Next one is QA, connect to pin number 13. Now connect pin number 14, VCC. Now we have to connect mode select pin, that is of pin number 6 to ground. So take black wire and connect pin number 6 to ground. Pin number 7 is ground of IC 7495. So connect ground pin. Now connect clock pin. It is right shift operation. So pin number 9 is connected to clock and pin number 8 is no connection. Now connect one wire in pin number 1 and initially that wire is connected to ground. Now just apply few clocks and clear all flip-flops. Now remove ground and connect that wire in VCC. Just apply single pulse, due to which QA become 1. Now just observe operation QA, QB, QC, QD in the ring operator.